Ocean Element. Ocean Element. Ocean Element. Ocean Element.
The latest smart packaging innovations for pharmaceutical sector, materials ideas in pharma, new developments for more flexible packaging and Q&A. And the last day is on 14th of July. Okay, for the last day, we have interesting topics from our president and Mr. Andrew as well. All right, and now, everyone, okay, so our mini topic today with the topic of pharmaceutical packaging in the core supply chain by Mr. Professor Pierre Pienaar. Okay, he's come already. So, ladies and gentlemen, all right, if you want to join us for this seminar, we will start as soon. Thank you very much, you all. May I attention, please? So everyone, our audience and honorable guests, today we have the special topics. Okay, as soon. All right, if you want to listen to our speakers, that he is very famous. All right, first of all, I would like to tell everyone about his biography first. Ladies and gentlemen, and this here, right here, innovation stage held in collaboration with World Packaging Organization and Informal Markets. The main topic of today's presentation is on importance of sustainable packaging in pharma. That's presented by the WPO's experts. And for right now, I would like to read a brief biography to our first speaker, Professor Pierre Pienaar, President of World Packaging Organization, or we known in the name of WPO. He will present on pharmaceutical packaging in the cold supply chain. Professor Pierre Pienaar's interest in packaging started in 1984 after having studied pharmacy. Soon after joining a large pharmaceutical company, Pierre became concerned about a number of packaging-related issues in the pharmaceutical world. He is packaging engineer in his own global packaging consulting business, Pactech Solution PRT Ltd, and has extensive experience in the pharmaceutical and food and beverage packaging industries. Over 35 years of experience in the field of packaging science and its related subject matter. He is the current National Education Director, past National President of the AIP, and past Vice President of the World Packaging Organization, or WPO, that everyone knows. Responsible for global packaging education, is regularly called to be an expert witness in court cases due to his extensive experience in packaging science, packaging engineering, and the technology thereof. He holds professorships in packaging engineering, is the 2022 recipient of the International Packaging Hall of Fame, and is the current president of the World Packaging Organization, or WPO, today. So, ladies and gentlemen, all right, please let me check. Everyone is ready. Are you ready? Everyone พร้อมนะคะโอเคนะคะเอาละค่ะสำหรับในหัวข้อถัดไปนี้นะคะกับ Pharmaceutical Packaging in the Cold Supply Chain นะคะโดยคุณ Pierre Pienaar นะคะ So ladies and gentlemen, please join me to welcome Professor Pierre Pienaar, the President of WPO. เชิญค่ะ
Very much, Nana. Nice to see you again.
Nice to see you as well.
Thank you. Sorry, I need that mic. Oh, okay. Very good afternoon. Yeah. A very good afternoon to everyone, and good to see you. Yeah. I'm going to talk about the cold chain supply, relating it to pharmaceutical. But I think before we start, we need to understand what is the cold supply chain and what does it actually mean to have products in the cold supply chain. And this was a problem during COVID-19, and a lot of product went wasted. And so temperature control is extremely important. And I use that word particularly, extremely important, because we threw away millions of COVID vaccine during the real pandemic years. So this is what I'm going to focus on, is what is this cold supply chain. So we've got to see it from a pharmaceutical perspective, and the important thing is it's the entire. It's from point A to point Z and everything in between. The problem is that the majority of product that breaches that temperature range, we only find out at the end. And then it's too late. The product is already destroyed. But it's holding the temperature consistent throughout the process. Maintaining all those good things that are involved in pharmaceutical manufacture like GMP. That's all part of it. We're just adding another aspect to it that makes it really, really focused on temperature control. I'll put this slide up here because it's a very good, very simplistic, but a very good one to remember. Because, and I know it relates to food, not pharma. So you can see right from that stage, from the farm, at that point already, we're having issues in the loss of product. I mean, at pharma or in food or in beverage, makes no difference, right through to the end, which is in our homes. The difference here is, and this is something that you folk must try and remember, between the farm and the processor is one phase. That's how we look at it in the cold supply chain. And from the process to the end is the second phase. Now, in developing countries, this is where the majority of the loss is. And in developed countries around the world, this is where the losses are. So that just shows you the areas where this loss is, and it is enormous. To give you some idea, in pharmaceutical manufacturing, the amount of product they throw away is $14 billion by their own admission per year. And that's every year. It's a lot of money they're throwing away of product. A lot of it relating to this breaching of the temperature and not monitoring anything there and then finding out over here. So we're going to look at the monitoring systems in a moment as well and give you some more ideas about this. So this is very subjective. Because for you guys and ladies in Thailand, for you, cold is very different to someone living in Norway. If I said to you, at what temperature do you put a jacket on in Thailand? And you'll probably tell me at around about, I don't know, I'm guessing somewhere between 18 and 20 degrees. I'm at 20, even worse. I didn't want to say that, but yeah, you heard it from a Thai. You're from Thailand? All right, and there you got it. A Thai guy's telling me at 25 degrees. All right, I can tell you, someone from, we've got a European in the room there. What temperature do you put a jumper on, Andrew? 12 degrees. All right, he's from the Netherlands. So it just shows you. So it's a very subjective, what is cold? What is cold to me and what is cold to you? And when we talk about the cold supply chain, we're not interested in subjectiveness. We cannot accept or tolerate subjectiveness. It's got to be accurate and maintain that accuracy. And this is where a lot of the problems are happening. This is where we are breaching that integrity area. So it's a focus into the future because we know that there was some even minus 70 during COVID. We don't really have those anymore. They've redesigned a lot of the COVID-19 vaccine, and so they're much more easier controllable temperatures. But there was a period where Pfizer did go down to minus 70 degrees, which was a massive challenge for the industry. Imagine that. They could do it maybe themselves, but the industry, the cold supply industry, were they able to manage it throughout the entire process? Well, we know in hindsight because, hindsight is exact science. But it's too late. The damage is already done. But we cannot allow that damage to be done again. And so the only way to do this is to control it, and to control it properly requires monitoring. Monitoring on an ongoing basis throughout, from the start to the end, at whatever temperature we choose. I think it's fairly straightforward. And throughout the shelf life, remember that as well. Shelf life doesn't mean just putting it on the shelf. It's shelf life for a cold product. That's the important part. You must understand that, because if one looks at this here, you can see how the temperature can potentially vary in the different stages. You can all see the diagrammatic images there. It all makes sense. Now, if we have a product that has to, say, be at 10 degrees, well, you can see all the areas where potentially we can have a problem. And how do we maintain that temperature throughout the whole process? That becomes the challenge. Now, you may say to me, I'm sure that's on someone's mind here, why are we having these problems now? We never had them 20, 30 years ago. You're correct. You know why? Does anyone in the room know why we have more problems now than we had 30 years ago in temperature control, in the cold supply? The reason for it is, 20, 30 years ago, we used to have one freighting company, maybe max two, that did the entire process from the start to the finish. Today we will have 5, 6, 7 and more. So now you're handing that product over to different freighting companies, and we're losing that control aspect at the handover points. The responsibility is diluted amongst all those. Now that's not me talking, that's the industry telling me this is their problems, because we as the World Packaging Organization have an association with the global cold supply chain, and there are two big global supply chain systems in the world. So we, in collaboration with them, we have signed a contract with them as to how can we help them to achieve their goals, but by us being involved from a packaging perspective. And that's where we learned of these problems that we're having in their particular areas. So now we change it, and we ensure right through the process and at the handover stages that those aspects are done. So that needs training of those operators at all those points. And one of the areas that we found was a big area of responsibility loss was at that changeover. So now we're educating those operators at each of those particular points. Now I mentioned to you about monitoring the process all the time. And the only way to do that is through data loggers. And there's a whole range of different data loggers. Bottom line is, we can log real time on a device, or we can actually use it directly into the cloud, and then we pull it off the cloud back in our office, and we can monitor it at any stage. At any stage, we can see the temperature inside those goods. Now, I don't know how many of you know this. Now, Thailand won't be any different. Anyone from Singapore? No Singaporeans? Okay. So in Singapore Harbour, which is a hub harbour, that's where a lot of freight comes in on a ship, it's changed over in Singapore on a different ship to the next point of call, wherever that is, southern hemisphere to northern hemisphere. So product could lie in Singapore Bay or on the wharf for up to 30 days. The only reason why I know this is because I've done live data analysis on product being exported from the northern hemisphere down to the southern hemisphere in Australia. And the problems where we had in that particular instance was of this excessive heat in Singapore. Now, it's not Singapore's problem that they have heat. We all know there's heat in Singapore. We all know there's heat in Bangkok. What are we doing about that heat in controlling our product? And we noticed that there were some stages that the product inside the containers, metal, steel, shipping containers, the temperatures went up to 70 degrees. Had we designed for that possibility? The answer was no. But only data loggers can tell us that. Live stream, we could see exactly where the problem was coming. So data loggers is so important. In addition to that, it's where the data loggers are placed in that container. Because there's no point just putting a data logger in there. We need to have strategic points in that, because we know that hot air rises, we need to have those data loggers in all the different areas within the container if there's no refrigeration. When it's refrigerated, different scenario. So, brings us to the next point. And where does the packaging industry get involved in this? Well, we can design packaging that can help to some degree in maintaining that temperature throughout. Now, I've seen a lot of packs on the market that are claiming to have temperature control possibilities. Well, that's not always the case. Not always the case, and data loggers have told us that. So these are various ways of keeping things cold. This one down here, this is actually wool lined. It gives the best results of all the current packaging on the market at the moment. They've lined it with sheep's wool. Yeah, can you believe it? Simple sheep's wool. It's sustainable, 100% sustainable, which is fantastic. The other systems, and this holds it below 5 degrees for 72 hours, not in refrigeration. 72 hours for up to 5 degrees, which is a huge plus for the industry, but people don't know about it. But in addition to that, when we are looking at packaging, we need to understand packaging and what aspect of the packaging do we need to redesign, be it the primary level, the secondary level, the tertiary level, the quaternary level, and do we need data loggers in those different levels that can feed us that information all the time. So just to recap, so you all know, the product coming into contact is primary, and where in secondary, it's where the primary packaging comes into contact, and tertiary is where the secondary packaging comes into contact with the tertiary. And then obviously you get all the others. And we have different materials depending on the type of product that there is. This is the sheep's wool, and that gets lined with a sustainable material so that the wool is not coming into contact with any product. But this has all been approved and ensured that there's no contamination at any stage. We also need to understand at the primary level what controls need to be done on that packaging. So I'm just recapping in terms of understanding, because what I'm finding in the industry, and not only here in Southeast Asia, I find across the world, there's a lack of understanding of what primary, secondary and tertiary packaging are. So how do you control it if you don't know what they are? And you can't always throw the focus on this level, on the tertiary level, which isn't always tertiary. In this case, it's tertiary. All right? You cannot put the pressure on this only when you should have fixed it at a primary level. So you have to understand the product. When we come to this one, I've added this one in here because sustainability must be a priority. And I've just given a lecture, and I know some of you were in that room. And it's important that we understand that this product, polystyrene, creates a lot of problems in the industry in terms of sustainability. And you can see the huge amount of polystyrene here, and we can see it in the sea. So we need to move away from polystyrene, and there are many other materials that can do as equal to or better than polystyrene. So we need to focus on this, and that's why I'm mentioning it. We don't need this. This is the Great Pacific Garbage Patch, and there's a lot of polystyrene amongst all that. Okay, so we focus on that one there. Once we know that what these are and how do these react to controlling the temperature. That's quite important. You can't just pick a insulative material without considering all the different levels. Once you've got everything together, now it makes it very straightforward in terms of determining which one is going to be the one I'm going to focus on. And then in this case, which is during the COVID vaccine, this is the one I was explaining to you where it's wool lined. And they got the best results out of that particular packaging, which was fantastic, and it was a solving situation. So we need to save on this waste. And I'm emphasizing this because it's in terms of pharmaceutical or medical waste, it becomes a problem. There's a lot of potentially toxic stuff out there on those dump sites. And we know that in nearly every country, a lot of people live on dump sites. And we've got to be careful and protect those people as well. So we need to not have those dump sites, and it'd be first prize. I mentioned to you a moment ago that according to the Sustainable Medicines Partnership, that's the amount of pharmaceutical product wasted every year, $14 billion. And we in the packaging industry can help enormously. So WPO, has a partnership with Sustainable Medicines Partnership to help them resolve these issues when it's packaging related. So where we've got wasted packaging or wasted product from packaging, we can solve 25% of that 14 billion, we estimate, we can solve it by packaging. So that's massive. Just divide that by 25%, and that's a large number that we are saving. I think it's about $3.5 billion we can help them in the packaging, because we understand the cold supply chain. We know how to build into it. We know how to work with developing countries as well as developed countries. There's blame on equal areas. There's no point the one blaming the other and saying that the one has a lack of infrastructure. There's issues in both areas of developed and developing. And that's the 25% that I mentioned that we can help them with. So how can we, you and I, look at, if you are involved in this industry, and I presume all of you are, the mere fact that you are at this expo, those are the items, and you can read as well as I can. These are the areas that you should focus on when you leave here and you're back in your office on Monday or whenever, in terms of focusing on what can be done to solve the supply chain issue, cold supply chain issue. And you'd be surprised that maybe none of those are your problem. Your problem might be just in the last one, for example. And I'll show you that in a moment, what I'm referring to. Okay, anyone know, other than Andrew Manley, anyone know in this room here, why have I got a milk carton there and I've got a shipping container here? What's the correlation? Anyone know the correlation there? Or why I have those two? The reason is, because this is one of the biggest problems that we have as part of the cold supply chain, believe it or not. And that is that there are a lot of shipping containers around, and we all know that everything that is shipped across from continent to continent is via a shipping container. We also know that a shipping container size hasn't changed, and it's not going to change. Not in my lifetime, and probably not in your lifetime. What happens in 50 years' time, well, I can't talk for that, but it's not going to change in the short term. The shipping container is here to stay in terms of that size. The problem is that the primary pack is not being designed for space efficiency in a shipping container. Now these guys, Tetra Pak, in around, 1980 odd, 1980, 81, 82, somewhere around there, they came up with a Tetra Pak. What they wanted was a 1 liter of fluid, of liquid. How come they designed this shape? Because they, Tetra Pak, understood the science behind space efficiency. So if they could do that 40 years ago, why are we making that error today? And we are. I can tell you we are, because I see it nearly every day across the world. Those errors are still being made by companies. These guys did it right 40 years ago. What are we wasting time and effort for? And because we are not filling the containers well and sufficiently, sure, we're wasting a lot of energy, which is affecting LCAs, life cycle assessments, but at the same time, it affects the flow of the air inside the container. Okay, I'm going to show you that in a moment. So when we make assessments of how do we reduce the loss, be that in food or pharmaceutical, it's all in the same arena when it comes to things that we are consuming. We look at all the areas. We've got to know where they fit in terms of primary, secondary, tertiary, and quaternary, and which area do we focus on in terms of that list that I gave you a moment ago. And how are we palletizing it? Because if we're palletizing it correctly, we get good airflow, which I'm going to show you in a moment. And then we can come up with, because remember, all packaging is made up of different fibers. We've got to understand the fiber technology, be that in polymers, because there's polymer chains, be that in paper, because there's fibers. And once we understand all that, now we can design properly. So it's understanding all the elements in the pack before we actually come to the point of correcting it. Otherwise, we're just going to make the error again. So if you see a pack like this, we focus on this bottom carton there, ensuring that the integrity of that carton can withstand the vertical load. All these elements point back towards the cold supply chain. Yes, they are relevant for every single pack, but in the cold supply chain, all of a sudden, we've got to make sure that this thing doesn't collapse, that bottom one, because it becomes soggy or wet or whatever the case might be, and then we have added issues in this thing. So we must understand the science, and I won't go through all this, but understand the science of material construction when it comes to corrugated packaging. Because most of us use corrugated cartons in that packaging. And again, I've shown you that one before, all right? And we really analyze it because, and we see by this, we can see the temperature in that data analysis where that temperature is fluctuating within the container. And what's more, within the carton, if the data monitors are in the right places. We can get real-time, accurate information for us to ensure that we design the carton suitably and the configuration, the stacking configuration of the cartons. And as I said, it tracked real time. We can see it all the way through it. Then we can now look at the container. All this I've been telling you points back to these diagrams. Wrong. Do not pack your containers like this. Now you think that's common sense? Well, I can tell you that sense is not common because I see it in the industry when you open containers and they're packed like this. The airflow, well, there's no airflow in this container, whereas you can see how it's packed. So now I'm getting airflow around all those packs, and that is vital. Vital, especially when we have a refrigerated container. We need to ensure that that airflow is maximized. And this is not being done by everyone in this particular field. So, I'm just recapping on this one really in terms of where those problems are occurring and my analysis of the losses, the issue, and then look at the opportunities once we've looked at the losses and found the issues. And we've done all that monitoring because that's how we find the issues. Because, and some of you have seen this image before, but we've got to reach a stage where we're back over here by 2050. And we're not going to be back over there by 2050 if we don't ensure that we use the right materials, they are recyclable, they are sustainable, and we are then back on track with One Planet Earth. At the moment, we're running on that red line, and that's where we're tracking at the moment in relation to the use of our natural resources across our planet Earth. Now, I don't know how many of you know this, 74%, so that's 3/4 of all new launches across the world will be in India, China, and Indonesia. So that's where we need to focus. And that's where the World Packaging Organization is focusing a lot of attention in those three areas because 74 of all launches, not only cold supply, I'm talking everything. So it just shows you that is where the focus of attention at the moment is. And we need to make informed consumer decisions in terms of pharmaceuticals to make sure that we're getting a product that is still at the right efficacy and that it's doing the job that it should be doing. And not take, like for example, in the early stages of the vaccine process, where there were vaccines taken that had breached the temperature controls and therefore maybe were not as effective as they should have been at the time of taking them. So we as consumers want to have that confidence that when we make a decision, it's the right informed decision. Only then do we get satisfaction. Thank you very much.
Thank you very much to Professor